so we've got different watersheds, we've got people fighting over water uses. How can you actually manage a particular watershed? How can you actually go about reaching protection? Riparian buffers are one specific strategy that you can take to do that. But if you try to put that in a larger context, how do you go about protecting a whole watershed? And a good case study about that here in South Carolina, it's actually got some national attention. There's a case study of the ACE Basin. H stands for the Ashtaboo, Pompey, and Edisto rivers, right? And primarily in Colleton County, although it creeps up into Charleston and Beaufort counties, and a couple of others there touch on a little bit. But in this area, they managed to protect about 10% of the uplands and the wetland habitat in this area through a combination of different entities getting involved here. So what makes this such an interesting case study? Because what you've got here is you've got local governments, state governments, federal agencies, private landowners, environmental groups, and land trusts, and local businesses all coming together to try and work together to preserve and protect the water quality and the habitats here. So it's a pretty big coalition of people that have come together to do this, which makes it interesting. And you can see here some of the different groups that have been involved. Colleton County, obviously, since they are the area affected by this, is taking the lead for the local agency. Department of Natural Resources, Fish and Wildlife Service, a couple different land trusts at the local level, the Low Country Open Land Trust, the Nature Conservancy, and then Westco, and Dutton Limited have also played a role here. Part of this is done through conservation easements. Who knows what conservation easements are? Other than Josh. What are they? What do they do? Yes.
That area of land inside a state land.
Right.
It's protected, you can do certain things on it, but you can't do other certain high development.
Exactly. So basically what you do with conservation easements, and this is how a lot of land trusts work, right? This is what they do. They try and acquire conservation easements in places. People voluntarily will give up part of their land use rights, but not necessarily the land. Right? And you can negotiate the terms of this to be basically whatever you want. You can have a conservation easement for, sometimes people do it not related to water quality or anything, but we want to make sure that this land is set aside for agriculture. So you can do an easement that way. You can restrict the land use for agriculture. In this case, what they're doing is they're saying, we're going to set this land aside, and we're going to maybe protect the stream by putting in one of these riparian buffers. We're going to put in buffers along our stream, but then once you're outside of that buffer, then right, going back here, then something like this, you're going to set this land aside as an easement, but the rest of us we're going to maintain for productive agricultural land. But we want to protect our waterways, so we're going to put an easement on in that way. So you can do it in a variety of different ways. But that's one way you can integrate a specific strategy into a larger thing. The benefit to the landowner on this is usually there are tax breaks for doing this, because you're basically decreasing the value of that portion of the land, so there's some tax incentives for doing that. And depending on what's worked out with land trust, sometimes those land use rights might actually be purchased. You might actually get a monetary figure for buying those land use rights from the place. So there's some incentives for the private property owners to do this. Private property owner then still can't buy and sell the land, but that land use right gets attached to that land permanently. Right? So if they sell the land, the next person that buys it is bound by that easement on that property.
And just want to interject that while the ACE Basin is our model in South Carolina, we do have these similar projects throughout the state. There's the Wallace in my region, but I'm pretty sure there's one in just about every region. Every watershed has one.
Right. This is probably the most famous one, so I picked that. There are lots of different versions and all sorts of different scales all across this state and other states. All right, the water energy nexus. This is one of the things that they really seem to emphasize in the national standards. And so we're going to go over here as best we can. It's also probably one of the most complicated things to try and piece together from all the stuff that we're talking about in our session here today. We touched on this a little bit earlier because we talked about how power generation basically is one of our biggest users of water, both groundwater and surface water. Right? These are some tables that we got from the National Envirothon, and there are links on there. So you can go get these and we'll be on our PowerPoint. But basically what they're doing here is they walk through water and power generation, right? So you can take a look at different types of power generation, right? And then you can look at, they talk about how they do the cooling process here. They talk about how much water is withdrawn and how much is actually consumed. And so you can start making some comparisons here in terms of, which one is more water hungry than the others. Right? So you can take a look at that figure and sort of work through that there. Some are more water hungry than others. Obviously, wind and solar photovoltaic are the least water. Right? It should be noted though that I don't know how much you guys know about this, but there's a couple different kinds of solar power. Anyone know what this one is? Concentrated solar.
So the mirrors and stuff.
Yeah, that's what the mirrors. What those mirrors are doing is basically creating heat to, boil water, create steam to power a generator, just like anything else. That also uses, a reasonable amount of water compared to some of these other ones. For example, concentrated solar actually uses more water than natural gas. Right. So when you hear the word solar, one thing to be careful of, if you're trying to do this sort of evaluation, is what kind of solar, because there's a pretty big difference between the photovoltaic and the concentrated solar. Right. This one uses very little water. Right. This one, if you're talking about just water use, you're actually better off using natural gas than you are concentrated water. So we can do the same sort of exercise. This is for transportation fuels. Right, you can go in there and you can actually look at water consumption. This one's a little easier to interpret because in this last column, they give you average gallon of water consumed per gallon of fuel, which is a nice way to go through and actually compare, energy source by energy source, what's going on, right? And so you can see that some are larger than others, right? Again, some of our best ones here, hydrogen for electrolysis is down around 3, 1.5. Oil and natural gas processing actually come out fairly low on the water scale, which is a little bit surprising and perhaps not what people would think, right? That in terms of water use, they come out okay. Now it has all sorts of other problems, right? When you're talking about extraction from oil. But in terms of just water use, it might not be as energy intensive as, again, depending on how you make the hydrogen matters here too. And again, this is just one estimate. So, some take-home messages here. That's just one estimate. Those ones are provided by the National Envirothon competition on their website, so definitely want to be familiar with that particular estimate. But do be aware that some of those estimates might change depending on who you ask and how they do the math. Right? There's a lot to think about in terms of what goes into those calculations, what goes into estimating how much water is being used there. And just one example of that, when you're estimating hydrogen and hydrogen efficiency, they break it out a little bit here, right? So this gets complicated because here they're saying they're getting hydrogen from electrolysis, here they're getting it from natural gas. You can see that makes a difference, right? Pulling it off from water, getting it from natural gas is a little more water intensive. But these make some assumptions also on how you're getting the energy to make all that stuff too. Right? So you need energy to make all these fuels. So these two things get tied together. And how much you assume, how many of these fuels are coming from renewables, how many are coming from nuclear, make a difference in the estimates. In fact, we have in the, I think it's around our links, there's a debate about hydrogen that originally came from someone posted a blog about it. And it was, well, hydrogen power sucked the lakes dry. Right, talking about how much water might be needed actually to generate hydrogen fuel. And it was a blog, so you got to do a little cautious about things to read on blogs, right? Right? Gospel truth over there. But it was reprinted in a bunch of different places. If you search for that, well, hydrogen sucked the lakes dry, you will find a number of different places, and they all trace back to the same blog. They got printed in a bunch of places and actually had some reactions to it. Again, how much you assume that hydrogen is going to decrease water versus increase water compared to say oil use, that depends on how you do the math and what assumptions you go into that. You can follow that discussion online if you're curious about that. But again, how you do the math makes a big deal. And how you generate the power makes a big deal. Right? Both in terms of water use and also just sort of overall how much